Good afternoon. Today we are going to see a brief introduction about the weldability of ferrous metals. So this is the introduction part. So first we'll be talking about the metals. So metals which combines with the other elements in the form of oxides and sulfides. So most probably we'll be calling this as metal ores. For example, iron ore like that. So we'll have a pure metal in the other form. So pure metals will be in a position that they will not be mixed with any other material. So this is the pure metal. So the metal listed in the periodic tables are all the pure metals. For example, iron, copper, zinc. These are all the some of the examples of pure metals. So next we will be talking about the alloys. Alloys are the mixtures of two or more metals formed together with other elements and materials to create some new properties with the materials. So mainly the function of the alloys is to improve the mechanical properties and other properties of the base metals. So these are some of the introductions regarding the metals, pure metals and some of the alloys. For example, when we are talking about the brass is a combination of copper and zinc. So whereas the stainless steel is the combination of steel and chromium. So basically when you are defining the alloy, there is a combination of metal A, metal B and some of the elements to enhance some of the property. Now we are going to see about the classifications of basic metals. So metals most probably they are being classified into ferrous and non-ferrous. So ferrous metals. Ferrous metals are the metals that contains the iron particles. For example, when you are comparing the steel which has iron and also the carbon. So the iron particles that with the combination of carbon forms a steel. Whereas when you are looking for the non-ferrous metals, the non-ferrous metals are the metals that do not contain iron particles. For example, zinc. Zinc is a pure metal. Bronze is copper and tin. So here in bronze there is no it won't have the content of iron. So these are some of the examples of non-ferrous metals. So the metals that are listed here, both the ferrous metals and non-ferrous metals. When you are looking on the ferrous metals, iron, carbon steels, that is the low carbon, medium carbon, high carbon, cast iron, stainless steel, tool steels, others. These are the some of the forms of ferrous metals. Whereas non-ferrous metals, aluminum, copper, brass, bronze, zinc, lead, tin, others. So we are going to focus mainly on the weldability of ferrous metals. So weldability. How we can define the weldability? It is the ability of being welded into an inseparable joints with a high weld strength. So basically in weldability, when you are increasing the weldability, the joints which are made there won't get separated easily. So some of the factors that affects the weldability are the melting point, thermal conductivity, thermal expansions, change in microstructure and surface condition. So these are some of the few factors that affects the weldability. So some of the properties that enhances the weldability are metallurgical compactability, serviceability, mechanical soundness, and so on. So we are going to classify the metals based upon the given tabulations. So metals broadly classified into ferrous metals, non-ferrous metals, whereas the ferrous metals is again classified into steels, cast irons. So the steel, plain carbon steel, low carbon, medium carbon, high carbon, low alloy steels. So these are some of the classification of steels, and whereas the cast irons can be broadly classified as grey iron, white iron and ductile irons. So low carbon steels. It is also called as a mild steel, where the name itself has the meaning low carbon. So the carbon content here ranges from 0.05% to 0.32% of carbon. So when you are seeing the property, it is tough, ductile and malleable, easily joined and weldable, poor resistance to corrosions. So it has a poor resistance to corrosion, often used as a general purpose material. For example, the pin, some of the basic elements that are using day to day life, screws, nuts are all the examples of low carbon steels. So next is the medium carbon steels. So medium carbon steel, it has the carbon content of 0.35% to 0.5% of carbon. So offers more strength and hardness but less ductile and malleable. Structural steels, rails and garden tools are some of the examples of medium carbon steels. High carbon steels, also known as tool steels, where the tools are all made. Some of the best examples are single point cutting tool, multi point cutting tools. All the tool materials are made in these kinds of high carbon steels. So the carbon content here will be 0.55% to 1.5% of carbon. Very hard but offers high strength and very less malleable. Examples: chisels, punches, saw blades, some of the examples of high carbon steels. So welding of low carbon steels. The welding of low carbon steels depends upon the section thickness, quality requirements. So the flex shielded metal arc welding, it is a common welding process for low carbon steels. Mild steels and low hydrogen electrodes are being used there for the welding process. And also the oxy-acetylene welding are also being used here. So the figure shows some of the welding done in the low carbon steels. This is quite a few examples there. So here this is some of the welding process done in low carbon steels. We can do submerged arc welding, MIG welding, TIG welding, plasma arc welding, thermite welding, resistance welding, electroslag welding and brazing process. So this is a live example. That's a photo of live example. So welding of medium carbon steels. When medium carbon steel is welded, martensite phase is formed in the heated zone due to the rapid cooling process. Sorry. So this is the welded joint that has been found in a medium carbon steel. So this is the welded joint. So it is hard, brittle and it causes crack easier. It is difficult to machine. So the welding process that can be done in medium carbon steels are flex coated metal arc welding. Low hydrogen electrodes are used. Preheating to be done 150 degree to 260 degree C. So the main thing is to have to preheat the medium carbon steel before welding process. Another one welding process can be that is the oxy-acetylene welding. So excess acetylene can be used here in this medium carbon steels. So resistance welding, thermite welding, these are some of the other welding process that can be used in medium carbon steels. So this is a quite example for the medium carbon steel welding process. So welding of high carbon steels. The welding process are here the oxy-acetylene welding can be used, where the frames that are to be used is carburizing frames that are to be used to reduce the defects found in the high carbon steels. Flex shielded metal arc welding. So here also the preheating process to be carried out at 730 degree C to 790 degree C. Mainly you have to do the preheating process to reduce the hardness and brittleness. So the electrodes used for the welding process can be a mild steel electrode, austenitic electrode and low hydrogen electrodes. So thermite welding can also be used and resistance weldings can also be used for the high carbon steels. This is a good example for the welded joints that are found in the high carbon steels. So finally the welding of alloy steels. The alloy steels is the combination of some percentage of alloy elements plus the percentage of steels that forms the alloy steels. And the purpose of alloying. These are some of the purpose that the need for alloying. So strengthening of the ferrite phase, corrosion, thus improving the corrosion resistance, to enhance the hardenability, grain size controlment, greater strength, improved machinability, improved low temperature stability, improved ductility. So these are some of the purposes or needs for alloying the elements. So this is the welded joints that are found in the alloy steels. So the tabulation that are shown here that emphasizes the composition and functions of a typical alloy steels. So the symbols are quoted shown here, and the alloying elements, percentage of composition and the respective functions are tabulated here. For example, when you are seeing C is the carbon and its percentage of composition is 0.2 to 0.4 percentage, and some of the functionality here are it affects the hardness, tensile strength, machinability and melting point. Whereas the same the Ni nickel percentage of composition is 0.4 to 0.7 percentage. The functionality here is the increases the toughness and impact strength. So these are some of the composition and functions of a typical alloy steels. So thank you for listening.